Hello everyone, in this session we are going to talk about extraction and sublimation. So we are gonna extract caffeine from tea, and then through the sublimation process we are gonna separate caffeine from the solution that is already in the solution. So for that, we need to know what is the caffeine. You see the chemical formula and the chemical structure. Caffeine is a white crystal solid, and so it's moderately soluble in room temperature, and very soluble in hot water, and also very soluble in organic solvent like dichloromethane. And you know that the dichloromethane is not highly polar, is moderately polar solvent. Um, you know that the glucose has two structure. You need to remember from uh, your organic class. As I explained earlier, tannin is one of the products of the tea inside the hot water. So you see the structure of the tannin. After hydrolyzation, you see it changes to gallic acid and glucose. And in the following, we are gonna have the reaction between gallic acid and carbonate sodium. So this is the tannin structure, which is one of the component of tea in hot water. As we mentioned earlier, uh, tannin is decomposed to two products. Both they are soluble in water. One is glucose and the other one is gallic acid. Gallic acid is reacting with carbonate sodium, and we have the salt of sodium gallic acid. And this reaction is meant to separate gallic, actually tannin, from caffeine. So we want to make sure that tannin is stay in water phase, and in the future when we have the DCM inside the funnel, we want to have all the caffeine inside the DCM. To give a brief summary for what we want to do in this experiment, first of all, we're gonna brew the tea with inside a beaker, and after having a tea, uh, we are gonna use the DCM in order to extract caffeine from the water phase. As we know, caffeine has a moderate polar structure, and also DCM is a moderate polar. You know that both moderate polar attract each other better. So caffeine goes to DCM phase and leave the water phase. So tannin stays in water phase, and we have the tannin decompose into glucose and sodium salt in order to make sure that we can contain the tannin structure uh, inside the water phase, and not to have it inside the DCM. So after that, we're gonna use the sublimation process to make the caffeine solid products. So as you see, each tea has three phases: caffeine, cellulose, and tannin. Cellulose is for the tea bags, and we have caffeine and tannin when we brew the tea in our water solution. So caffeine is soluble in hot water and very soluble in DCM, either room temperature or higher temperature. So at the end of the work, we are gonna evaporate DCM, and then we are gonna sublim through the sublimation, we are gonna obtain pure caffeine. So you know what is the sublimation. Changing from gas to solid is the sublimation process. That's the definition for the sublimation. And for the tannin phase, which is very soluble in hot water, we are is going to hydrolyze it in base, which is the carbonate sodium, into salt of gallic acid and glucose, and separated by extraction. So these are the equipments that we need: a beaker, 5 tea bags, carbonate sodium, heating plate, separatory funnel, and a stopper and stopcock. And we need ring, a few clamps. We need DCM in 4 portion of 10 milliliters, and 2 right size beakers for the last part of the experiment. So first of all, we are gonna brew the tea, and in that step, we are gonna brew tea inside the carbonate sodium solution. It is possible to brew tea inside water and then add carbonate sodium. Both are possible, but through this procedure, we have carbonate sodium first dissolved in the hot water, and then we brew tea. So you see what are the equipments we need for this part. After brewing, we are gonna separate tea from the tea bags through vacuum filtration that you are already familiarized with this step. After that, we are gonna separate caffeine from the tea solution, which is already tannin. So for that, we are in 4 steps. We are gonna add DCM and then shake for some amount of time. After that, when we put the funnel on top of the ring and wait for a few minutes, we see that they are gonna separate DCM phase and water phase. They are gonna separate. All the caffeine is going to in DCM phase, and tannin is staying in water phase. So we are going to do this step 4 times. In each step, after separation of the DCM from water, we take out the DCM phase from water, and then again repeat the adding pure DCM into the solution and shake, and then wait, and then extract. So we are taking out all the DCM. We know that in this step, all the caffeine is going to the DCM phase because they are very soluble in DCM. Caffeine is moderately polar, and DCM is also a moderately polar solvent. And you know that the water is highly polar, so caffeine has a higher affinity to go to DCM phase. So for after that, we are gonna use the gravity filtration to filter the mixture of the DCM and caffeine to separate if there is um, any any solids, anything other than caffeine and DCM. So after that, we are heated. We are going to heat the DCM with the caffeine inside the large beaker, and we fill the small beaker as you see. And after evaporation of the DCM, you see that you see caffeine start evaporation, and because we keep the small beaker very cold, so we have the situation that we can see the sublimation of the DCM inside the exterior wall of the smaller beaker. So we heat the DCM and caffeine in the larger beaker. We have the smaller beaker filled with the ice, and then we keep the small beaker inside the larger beaker. So after evaporation of the DCM, uh, we have the we have evaporation of caffeine, and then because the small beaker is very cold, we see the sublimation uh, a physical process of the sublimation is happening on the exterior wall of the smaller beaker. This is what is going to happen. So you need to scratch the caffeine crystal from the exterior wall of the smaller beaker, and at the end you see what waste and uh, we need to throw into the designated area of those waste materials. Thank you for considering this uh, explanation of the extraction and sublimation process.